with reference. If you have a formula like the parallel resistor formula, you're not allowed to just use formulas like you like. You must tell me where it comes from. So you make 3 dots, dot, 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 and you put square bracket 3 there. Square bracket 3. That 3 next to the formula tells me out of which book does this formula come. That comes out of book 3. Okay, we've got another formula for the capacitor, this one, C is E naught area over distance. That formula dot, dot, dot comes from reference number 4. So book number 4. This is a different books on that one. That's why that's a 3, that's a 4. So this square bracket tells me which reference you used. If it's an internet, like you've got a picture on the internet like this case, there's your picture in your report. The picture is here. It comes from reference number 5. Maybe that is a World Wide Web internet reference. It comes from there. So you say pictures, there's your picture. Dot, it comes from reference number 5. So that we know where does it come from. So your last page then is containing the references. So for that formula, it was, remember, it was number 3. So it will be number 3 here in basic electrical circuits. So number 3, reference 3, that formula comes from the book basically. So this is your reference page, chapter 7. Remember, we've got 7 chapters in the report. You've got 7 chapter numbers. It's not the page numbers. The page number is something different. The page numbers you put here on the bottom, maybe it's page 14 here. So it's not, don't mix up the page number with the reference chapter, the chapter number. So your last page is the references. And like I said, that formula was formula 3 with reference 3. It's square brackets 3 and it's basic electrical circuits. Reference 2, that formula came from S.J. van Zyl, this book. And formula 1, maybe your teachers from high school, you had a formula there. You give the teacher's name there. Sure. And that reference comes from there. All right. Also, yeah, for instance, 6 is your high school teacher. And then you can maybe see reference 5. There's a photo, and you copy it from worldwideweb.d2lo.com. So you copy it from that address. So this last page is basically the book names and the internet link, the internet addresses, the World Wide Web what. That's what this last page is about in your report. And we call it your references, your reference chapter, chapter 7. So you've got now an idea how to referencing. So make sure you reference all your formulas and your calculations counts 20%. So don't give me one calculation. I'll get you 1 out of 20. People, you must show about 20 calculations in detail. Show them how you've done it. So don't show shortcuts. If you haven't done your report right, go and make another one, improve it, and post it again tonight. So don't just leave it when you get that mark. Go and improve it. You still have time until Saturday. You can put another one. I don't care. I'll mark the newest one. Okay, any other questions on this? Guys, do you have any other questions on that?
So you're saying we can submit the assignment on top of the assignment that we've already submitted?
Yeah, just assign another one. Make right your mistakes and just improve it. Okay, it's not a problem.
Okay.
No, I'm not like the other lectures. I only give you one chance. Like you all can see, I gave you like 2 chances now. That's your time. And you must be very happy today. But I don't mind as long as you learn out of this and learn how to write report. My aim is to let you learn how to write a report. It's not. I just want to just fail you. But tomorrow night I must close the report so I can start marking. I have to start marking too. You know. Imagine 120 reports. I must do that. It will take me 3 months to read. So that's why there's an end date, a final date. It must close. Okay.
So the other thing that I couldn't understand is how I'm supposed to calculate the LED's voltage.
Okay, I'll show you here. No, man. Just give me a second. So guys, here it is. Let me just explain so there's an LED here, for instance. I'm going to just draw it like that. And there is one resistor. And then there's your battery voltage. So say this is 10 volt. And say the LED voltage is 2 volt, the volt drop over it. There's 2 volt over the volt drop. So you measure with your multimeter, you see it's 2 volt or 2.1 volt. So now we want the total voltage over the circuit, not over the LED, to calculate this current. To calculate this current, I cannot use this voltage as part of the circuit. I need the voltage only on the rest of the circuit, not the LED. Now what I will do, I will say 10 volt minus V LED equals V total in that case. So the V total for the rest of the circuit now will be 10 minus 2, so it's 8 volt. So the 8 volt will fall over the rest of the circuit here. It's indicating with arrows, so my circuit is, now I can only calculate the total current. So if there is a 8 ohm, for instance, I will say I total equals, which is different from 10 volt. Né? It's 8 volt divided by 8 ohm. So 8 volt divided by 8 ohm. And that is 1 amp. Otherwise, you set 10 volt divided by 8 ohm, which will be 1.2 amp, it will be wrong. So this is the right way to calculate it. Have you got it now? Any other questions, guys? People, please ask me any other questions. Okay, no questions. Let's get on with new work. So today, I want to talk about capacitors, but not only capacitors. I also want to talk about Thevenin and Norton. So I'm going to just explain a little bit of Thevenin and Norton. People, if you have a complicated circuit like this, and I'm going to do Thevenin first, and can you see the word Thevenin there? Someone please respond. Where's the class?
No, we can't see.
Can you see it now?
No.
Can you see that now?
Yes. Right.
So don't say no, guys. I want to know where the camera starts seeing. Can you see that word clearly? People, I'm waiting for you. You will wait forever while we're recording. Please tell me, can you see it clearly?
Please rewrite, sir.
I don't hear that. Okay, so when we've got a circuit with a resistor and another resistor in, say for instance like that, and we've got the output terminals there on the right hand side, and the load resistor is the RL. We call it the load resistor because it's at the output terminals there. So say there is a 4 ohm and there is a 8 ohm. So I want to calculate the Thevenin voltage and the Thevenin resistance. What I need to do, I need to have one voltage and one resistor. That's my Thevenin equivalent circuit. To have one voltage and one resistor, I must simplify these resistors. So there's 2 or 3 steps you must take. So step 1, is you short the power supplies or all the batteries. So short the PSU or the source. We short that. And the second step is calculate the resistance. And let's do these two steps now with this circuit. And this is what I need to do. So the first thing, I'm going to short it and I'm going to use a red pen and I'm drawing a wire across the thing, a thick red wire. I'm shorting it out. It doesn't exist anymore because there's a wire across it. That wire makes the 0 volts. So now I can see that the 4 ohm is suddenly in parallel with the 8 ohm. Can all of you see that they are parallel? This hand is holding on that hand, and this hand here for the 4 ohm is holding on that hand of the 8 ohm. So they are in perfect parallel. Can you see that? Then I redraw the circuit and I will have now my 4 ohm here and my 8 ohm in parallel with it. And there is my source still there. And step 3 is actually here. My third step is remove the load. So I also remove the load. So in this circuit, the load is not there anymore. I remove the load. I shorted that, and then the 4 ohm is in parallel with the 8 ohm. I solve the circuit, and then I'm landing up with one resistor and one voltage source. Now, when I short this, I can see the form is parallel, so my math goes like this. 4 parallel with 8 equals 32 divided by 12. So it's 32 divided by 12. And can anyone calculate it for us?
Excuse me,
Guys,
sir.
2.7. So that is 2.7 ohm. So now I'm sitting with the circuit and the total resistance for the circuit is 2.7 ohm. I redraw again. So I redraw once, I redraw second time, and I redraw third time.
Excuse me, sir.
Now, when I'm reading it and redrawing it, I'm putting back my load resistor and I'm putting back my battery and I'm using this Thevenin resistor. So we call it R Thevenin. That's the value now. So my circuit, when I redraw it again, my final circuit will look like this. And I will have my battery. Say that was a 10 volt battery. I'll have my battery there. Guys, there's some people's microphones is on. Just put it off, please. Don't leave your microphones on. So there's my 10 volt battery. And there is my R7 of 2.7 ohm. There it is. And there's my output terminal. And now the resistor that I've removed the load, I'm putting it back. So I'm putting RL back there. R load. The load resistor. So there's my two terminals. So this is my final solution, and this is one you get your marks for. So 1 mark for redrawing, 1 mark for this, and for R7, and in V7 will be this voltage that I've put back. So I can calculate my current now. So say that was a 10 ohm. This R load was a 10 ohm. So my current will be, the total resistor will be the Thevenin resistance plus the load resistor, which is 12.7. So our total is now 12.7. So I in the load, I want the current in the load equals Thevenin total over the total resistance, and that is 10 volt divided by this 12.7, because that will be 10 over 12, so it's about 0.9 volt or so, 0.8 ampere, sorry, ampere. Guys, do you see how to do a Thevenin circuit example? Can you see the drawing clearly at the end? Can you see the drawing clearly at the end, guys? Okay,
No,
any
sir.
questions on that? Ask me if you
Yes.
want it.
Yes, there's a question.
Okay, what question is that?
First of all, say I didn't get how you said resistor 4 is in parallel with resistor 8.
Okay, go and look at this video again so that you can see what I did. I shorted the battery out, and that puts 4 in parallel with 8. Remember I said it in the beginning of the video? So replay this video on bright space again. And watch from the beginning how I placed 4 in parallel with 8 by shorting out the battery. That's basically the technique we use here. Okay. Let me do another one, then you'll understand it better. Okay, second example. Can I do another one?
Yes.
This time I want to do it with a Norton circuit, so I'm going to explain a Norton circuit. And this is Norton. In Norton's case, the 3 steps is I open the current source. Okay, I'm not shorting it, I'm opening it. And then I calc the second step, I remove or load. And then I calculate our total again. So it's slightly different, but look what I'm doing now. So in the Norton's case, a current source looks like this. It's an arrow in a circle. It looks like that. And there's a resistor in parallel with that. Say it's a 2 ohm. And say I've got another 2 ohm there. Now let's make it a 4 ohm there. And that is my Norton circuit. And I've got another one. Say I've got another ohm, another 8 ohm there. Right, there's my circuit. My 2 output terminals is there, and my load register is here. R load. We call it RL also. RL. Say that is 10 ohm again. So this is a 1 ampere current source, and current flows now through the circuit, 1 ampere. So the first step I said we open the current source. So when I redraw, the current source will be open, so I'll just have my 2 ohm there with no current flowing now because I've opened it and I removed the load register. And then I've got my 4 ohm there, and I've got my 8 ohm still there. There it is. And there's my 2 output terminals. And remember, the load has been removed there. I'm making a red cross there. And we've opened the current source. We don't short it like a voltage source. In this case, for Norton, we open the current source. So it's gone also. Bafana, Bafana. My Bafana rule. You throw away your problems and you solve it. You make it easier. Now I can see that the 2 ohm is in series with the 4 ohm. There's nothing here. So that makes the 2 ohm in series with the 4 ohm. The 2 is not parallel with the 8 because there's something in between. So the only thing you can do, 2 is in series with 4. So my math will go like that. 2 plus 4 is 6 ohm. So I've got a 6 ohm there now. If I redraw that 6 ohm, it sits like this. And there's my 8 ohm. And there's my 2 output terminals still there. So this 6 ohm is in parallel with the 8. 6 in parallel with the 8. So my mathematics for that is 6 parallel with 8. It's 48 divided by 14. That is 48 divided by 14. And if we divide that, we get the answer, and it's 3.43. That is 3.43 ohm. And that is R Norton. R Norton, not R Thevenin like previously, R Norton. So then I finalize my circuit and I redraw. Let me shift a little bit up now. And when I redraw the circuit, I'm bringing back my load resistor and I'm bringing back my current source. And what I then have is my current source here.
So can you shift it more up again?
Okay. Thank you. And then I've got my current source, and then I'm parallel with that because this is in parallel with each other. I've got this parallel value of 6 and 8, which is 3.43 ohm, 0.43 ohm. And I still have a 1 amp. I just write 1 amp current source there. I'm just placing it back, the current source which I removed. I'm placing the load resistor back, which I've removed. And my load resistor will then be here. My 2 output terminals there, and my load resistor will sit there. And it was 10 ohms, so my 10 ohm is back. Now I'm done, and I can solve my current through the load resistor. Usually the exam papers, I ask the current through the load resistor. So to get this current, I can see there's a current here, and it's dividing into 2 legs, current divider law, remember that. So I'm going to say this current, I10, equals, I'm going to write it here, I10 equals, do you still remember the law? It's 1 amp times that resistance divided by that resistor plus that resistor. So it's 1 amp, 1 ampere times this one, 3.43, 3.4, divided by that one plus that one. So 10 plus 3, 13.4, divided by 13.4. So it's basically then 3.4 divided by 13.4. And that is 0.254 ampere. That is 0.23. What did I say? 0.2.
Sir. I say,
Yes. Any questions?
is that for current passing through resistor 10 or passing through resistor 3.43?
Again, go and relook at my video. I explained it very slowly and I showed which current it is. So relook at this video again because you did not see very clearly. Go to Brightspace after this recording. Look at it again, but I'll tell you now what it is. It was to get the final current through the 10 now.
But so do we multiply the
I said
total
it in the
current
beginning.
with the resistor 3.4 or we multiply with the resistor 10?
What are your question?
If we want current for I10, do we have to multiply it with the resistor for 3.43 or for resistor 10?
No, remember that's how I teach you. Remember I teach you that? If you forgot your formula for current divider rule.
I
The
remember
current divider
it.
rule works like that. If you want this current, you must multiply that resistor with a 1 amp, okay?
Or the
And
inverse.
then
Oh,
divide by that plus that. Remember that's on page 65 in the handbook, guys. Let's go and reread your books again. They're on page 68, sorry. On page 68, here's the formula. Do you still remember the formula on page 68? There's page 68. There's your current divider formula. Do you still remember it?
yes, I see it.
Go and revisit this page. You had it for homework 3 weeks ago when I did this. So just go and look at that current divider law, how it works, and there's the formula. So I'm just using that formula. I'm not teaching new information today, just old information. And I know you guys are a bit overwhelmed and so on, but go and revisit the stuff there on page 68 so that you can be sure how to do this again. And this is how we do a Norton circuit and a Thevenin circuit. So I'm going to conclude that. And what I will then do, I will quickly move to capacitors now. Or do you have any other questions about this now? Thevenin and Norton. These two. Do you have any other questions on how to do Thevenin and Norton? The difference is that, remember, the only difference between them is, in a Norton is a voltage, a battery, and we make a short circuit over it. So I'm shorting this voltage out here. That's what I'm doing. And that is why the 4 ohm goes in parallel with the 8 ohm. So for Thevenin, we short the voltage. For Norton, we open the voltage of the current source. Sorry, not the voltage. There's a current source for Norton. We open it and it's gone. That's why there's a red cross here. And we also remove the load. That's why there's a red cross there. And that's a small difference between Thevenin and Norton. All right, guys, I'm done with Thevenin and Norton. You can revisit the video, what we are recording here today. I'll put it on bright space for everyone to see. Group A, N1, N2, and N3 can all look at the same video. I'll put the link there on bright space for you today. So, guys, I'm done with Thevenin and Norton. Monday and Tuesday, when we are back in class, we will give some problems with this. And we can do some problems. I'll let you do a few problems with this. So with capacitors, I'm just going to recap quickly because I see a few people came extra here today. They can be very glad that they came because this is a very valuable class and a very valuable information I'm giving here. So let's recap. For capacitors, remember, if we have a circuit like this, I'm just going to write, and I'm going to recap a little bit stuff and teach you a new formula today. So for capacitors, if I have a circuit like this, with a resistor and a capacitor there, in series with it, say this is 2 farad, and say that is 4 ohm. And this is a 10 volt voltage source. So for capacitors, the first thing we need to do is calculate what is tau, the time constant. How long does it take for this capacitor to charge up? It charges up with the E curve, remember that, and it takes time, like my pen here, it takes time to charge up to the final value of 10 volt. We call this the final value, or we call it Vmax. We call it Vmax also. Sometimes we call it Vm for Vmax. So this final value is almost 10 volt, it's 9,99999, and it will charge up. It takes a certain time delay to charge it. So that delay is, we call it tau, and tau is the value it reaches after 66% charging full. It will reach this value of tau. Now tau, the time delay, we saw that yesterday, is RC. So resistance times capacitance. So in this case, tau is 4 ohm times 2 farad, and that's 8 seconds. So it's 4 times 2, and it is 8 seconds. So the time delay will be 8 seconds. There you are. So let's just then talk a little bit more about this E curve. And the E curve charges up, and I'm going to show you the formula now in the book. And in the book, on page 230, I'm going to say page 230. You must go to page 230 in the book. So guys, if you don't have a book, get a book, get hold of it and look at page 230. And this is page 230. And I hope you can all see it. Let me put it closer to the camera. So this is the charge curve and the discharge. Sorry, that wasn't 66%, it was 63%. So I'm just going to modify it here. It's 63% of the value. So it will be, if the max is 10 volt, then it will be 6.3 volt here, where tau will have its time delay of 8 seconds in this case. So towers RC. Here it is in a book. This is the formula on page 230. So go and look at the stuff there and how the charging curve looks. And the formula for charging a capacitor is this one on page 231. And there's your formula. Do you see this formula there on top, people? So V equals V max times 1 minus E to the minus T over tau. That's the formula on page 231. So let us write that formula down and explain it better to you. So what we're going to do now, if I want the instantaneous value on this graph, I'm going to look for VC. We call it V charge. It's charging up. So we usually call it V charge. So the formula for V charge is VC equals V max, which is that 10 volt there, the final value, it's V max. That's V max times, and I'm going to put it in brackets, times 1 minus E to the power minus T over tau. And there you are, a very simple formula. And let's plug some values in it. So we know the time constant is 8 seconds. So this point here will be after 8 seconds. This is 0 seconds. So it will delay 8 seconds. And it will find this value there of 6.3 volts after 8 seconds. So if I ask you, what is the charge voltage after 10 seconds? It's a bit more than this. So it's about here. 10 seconds, it's about there. 10 seconds. So I want this voltage here. I want VC there. So I'm going to write VC in red pen. It's not very clear, but this is a VC. And that point is after 10 seconds. So then I'm going to plug in my values here. And then I'm going to do the problem. So Vmax here, we know it's 10 volts, right? So that's your power supply there. So it's 10 volt times 1 minus E. Now, T is 10 seconds. So time is 10 seconds in this case. Because I'm giving you that. I'm asking after 10 seconds. So you put 10 there. So minus 10 over tau. Tau is 8 seconds. So it's 10 over 8. Minus 10 over 8. And that is the formula. So guys, can you calculate this and give me the answer? Do it in class now. I'm giving you a little time. Calculate for me what's the charge voltage at this 10 seconds delay. What is the voltage there at that point? So I'll give you guys 2 minutes to do it. Plug it in your calculators and do it for me. I'm not doing it because I'm not using calculators, so that's why the class can do it for me. When you're done, put up your hand and we'll ask you. And the first guy that's right will get the sweetie. I will email it to you because I'm not with you now. That's the only disadvantage. I have to email it with you. New, yes, talk to us.
7,135.
Oh, New says the charge voltage is 7,135.
What's the value for E?
E's on your calculator.
Oh,
E's there on your calculator. The value for E. E to the 1, E to the power of 1 is actually 2.71. So press E and test for yourself, guys. Press E there. Go to your calculator, press E, and you'll see there what E is. E to the power of 1. And then you say it's 2.72. So the value of E is just a constant, but it's in your calculators, and it's basically 2.72.
right, 7,13 is correct.
Okay, thank you very much. So you get a sweetie, come Monday and get it from my office, or I must email it to you. What do you prefer? Email now or Monday?
Yes, I'm coming, sir.
I don't like these classes, guys. I can't email these switch. I like a real class. I can just give you.
Send it on WhatsApp.
I can even WhatsApp it to you. What's your WhatsApp number? Guys, you are mechanical. You must now invent a 3D printer that can print sweet and chocolate. I want one. I want to order one so I can WhatsApp it to people and they just print it there where they're in their house and they have it. How's that? A 3D printer that can print chocolates. I'll order that one first. I like chocolates. Who else likes chocolates? Okay, but you'll see soon, very soon, the technology is going within 5 years. If I make a 3D printer in your house, you can print any chocolate there and just eat it right there, as much as you like. Someone will invent it. It's not so difficult. Right, guys? Are there any questions? Are there questions about this stuff? Can I carry on? Can I quickly?
Yes, carry on.
Yes, sir.
So we've charged the capacitor up now, right? So the next page, we want to discharge the capacitor. So now we've got a circuit and capacitor discharge. The capacitor discharging. Now to discharge the capacitor, what we'll have, remember we've charged it up to 7 volt. So remember we've done this now, and we've charged it up. And we reach this value of 7, what was it? 7.1 volt. 7.1 volt. We reach that value. And now at that value, we want to discharge it. So the E curve will look like this. We're going to discharge it. And remember, I said after 8 seconds. So 8 seconds will be basically, no, tau was 8 seconds. The charge time was until 10 seconds. Okay, so now we want to discharge, let's say up to 15 seconds. So we want to discharge up to that point. I'm going to use a red pen because the black is now a bit confusing. So I want this value here. VD, V discharge. That's a VD that, if you can't see it. So I need to discharge voltage. And now I'm going back to my book. And in the book, I'm going to page 230. And I'm checking out my discharge formula. And in a book, I found a formula. And this is the formula for discharging on page 231. So I'm going to say page 231. That's where we are now. The formula is there. I go to my formula and I see that's my formula for discharging. So to discharge the capacitor, let's do it. So now that formula is, let's write it here, V discharge equals V max times E to the minus T over tau. It's very simple. It doesn't have that 1 minus anymore. It's more simpler here. So my time is now 15 seconds. So I put 15 in the time there. My tau, which is the time constant here, remember that's still 8 seconds. So I put in there, I put an 8 in there. Okay. E still remains. But V max, what is that now? It can't be 10 volt anymore. 10 volt was there. It's now 7.1 volts. So we're putting this lower one now in there. So 7.1, this one goes into Vm. So there's my formula. V discharge equals 7.1 E minus T over tau. So it's minus 15 over 8. Minus 15 over 8. So guys, tell me, what is the discharge voltage after 15 seconds? What will it be? I don't have my calculator, so I expect you to do it. Give me the answer. The first guy with the answer, King. I will email it. Another
1.1.
What's your name? Swagger says it's 1.1, eh? There it is. So it's 1.1 volt. So we discharge now to a lower voltage and it reached 1.1. So that is now 1.1 volt there. So this is how the discharging of a capacitor works. You guys got it. Any questions on discharging a capacitor? So you must remember the trick is you must start VM in this case will be from the place that we're starting, which is 7.1. We charge up to that and now we're discharging. So that's why I'm using 7.1. Okay. People, does that make sense? Are there any questions on this new work here? If there's no questions, I'm going to just bulldoze on. You know me. I don't go back. So stop me right now and ask your question. Do you have a question on this stuff? Is it as clear as mud? Are the smoke coming out of your ears, guys? Are you tired? Why are you not answering? Okay. So this brings me to the next part in capacitors. I'm concluding this now. There's no questions. I'm going now to capacitive energy. And at this point, I'm going to the book and I'm looking for my formula there and I see that energy is there on page, let me just find it, page 235. So in the book, I'm going to page 235. Guys, do you like this type of lessons? I give you page number, your formula, and the stuff all over Brightspace. How do you like that? That's page 235, and I'll show you the page number. There it is. If you don't believe me, there's my formula on energy. And the book explains energy here very well. So I want you to go and read your book. And I've got an explanation here of the energy stored in a capacitor. Go and read that so to make sure you understand the stuff and reiterate the stuff. You can even Google the stuff. It's on Google too, this formula. It's not a problem. But the formula E is half CV square. Do you see that one? It's very similar to the one you learned in grade 10 or so, where you learned about energy is half mv square, where there was speed of a mass. Do you still remember that in school in science? This formula is almost exactly like that formula. So E is half CV square. So energy equals half CV square. Right. In this case, we've got maybe a battery again, a 10 volt battery, and say we've got just a capacitor there, and say that capacitor is 2 microfarad. Do you still know what micro stands for, guys? Engineering unit is micro, né? Do you see that engineering unit? 2 microfarad. And there's 100 ohm. So we know the voltage is 10 volt, and that's 2 microfarad. So here's my formula. So that is 0.5 times 2 times 10 to the minus 6, because it's microfarad. Okay, times the voltage square. So 10 square times 10 square. So guys, what is the energy? Calculate it for me, please. While you enjoy it so much here in this enjoyable class. What is the energy there? Can you do it for me? What is the energy? People, it's very simple. I can do it even in my head. I don't even need a calculator. Must I do it? 10 times 10 is 100. 100 times 2 is 200. And divide by 2 here is 100 times 10 to the minus 6. That's 100 microjoule. Who can give me the answer? I've done it in my head. I don't use calculators, guys, so I just do it like that. It's very simple. What's your answer? What did you get? Someone wants to tell me. How much you get?
100 microjoules.
So tell me, how did I know it? How did I know that? Do you think I used a calculator? What is your name?
No.
New set is 100 microjoule.
Joules.
And new is right. It's 100 microjoule. Okay, you don't need a calculator, but really, guys, you must just understand how the 10 to the minus 6 thing work, and that it's a micro, and that's why it's a microjoule again. That is the engineering units, guys, which you must learn. You must know your engineering units. This thing, you see that little thing? That is engineering units. That little thing, engineering. It means 10 to the minus 6. That's the meaning of that sign. That funny Greek sign. It's an M sign in Greek, did you know? No, it's Greek for me too. Not for only you. So guys, any questions on this? Am I overwhelming you today? Am I going too fast? Do you want to slow down? Do you want to ask a question?
Is there like any way we can do like practice of this kind of topics, like maybe question papers, if I can like find, one can find them?
Okay, the papers. I'll shift this up a little bit and I'll just show you where the papers are. The papers is on the TUT website. Let's make a new page, TUT website there. And then on the TUT website, you go down. There's a lot of stuff there on TUT website. And one of them is exams. Did you see that page? The exams page on TUT website. So under exams there's a lot of stuff there. But basically there on that exams page there's a little thing there that asks for your student number. You put your student number in there. And then the next block it will ask you, after you've done that, it will ask you what subject. So the subject you put into the next block is the subject code. You can either do the subject or by subject code. No, it's EEN 111T is one subject code. There's a lot of papers under that subject code. It's my old subject. And then also ETT 101T and also what is this one? EEN 115C. There's 3 subject codes for you. You type in the subject code there, and the exams department will show you then papers for this one. There's about 30 papers here. About 30 papers here. There's about, I don't know, maybe about 10 papers on this one. So there's no excuse. The papers are there. You must just go to your exam website. All the papers are kept for you, for your convenience to pass. And if you do papers, you probably get 80% for the subject. So just go and practice them. And if you can't do a certain problem, bring it Monday to class or Tuesday. Bring your problem in, and let's see if we can do it there in class. All right, guys. Is everyone happy so far? Any other question? Guys, can I stop this recording? Can I stop the recording and can I then finish this thing? Are there any other questions? Please ask me quickly. Stopping.